during the whole talk. We are collecting them for the speakers. Our next speakers will be a debate discussing damage assessment, and I'm very happy to welcome Cristiano Giovando from Impact Initiatives, Marc van den Homberg of the Netherlands Red Cross 510, Matthew Wencel of REACH, Antoni Ross Martinez with HOT, and Kyriakos Kouparis with WFP, again discussing damage assessment. And also to let you know, in the other room will be a talk about geospatial ethics, philanthropy, politics of representation. So feel free to check out both of these talks. All right.
Thank you, Lily. Can everyone hear me okay? Yep.
Yep, loud and clear.
Okay, thank you. And thank you, everyone, and good morning, Americas. Thanks for joining today. We have a session that is a debate, but we also have 4 presentations from 4 presenters that will be also on the panel, on the debate session. So I'm from HOT. My name is Cristiano. I'm from Italy. I'm a technical advisor with HOT. I've done some work and research on damage assessment, but since we only have 25 minutes and we have 4 other people participating on this panel, let's hear from them. On the panel today, we have Matthew from REACH Initiative, Kyriakos from WFP, Marc from the Netherlands Red Cross, and Antoni, who's the HOT Disaster Services Manager. I will let them introduce themselves and present some work related to damage assessment, just a few minutes, and then we'll come back with some questions and debates and debate after that. So Matthew, off to you.
Thank you. So my name is Matt Wencel. I'm the Senior Manager for GIS and Remote Sensing with Impact and REACH based in Geneva. And as we're...
You're a little quiet, Matt.
Oh,
sorry.
Is that any better?
A little better, thanks.
Okay. So as we are a bit short on time, I'm going to jump straight into the presentation I prepared. All right. And so to just give you a bit of background, Impact and REACH are regularly involved in humanitarian damage assessments in every context and phase, so from sudden onset disasters to protracted crises and complex emergencies. And more we're looking at recovery, building rehabilitation and reconstruction in post-conflict settings, notably in Iraq. And just a couple of examples, these are some products related to natural disaster, and one of the bigger ones related to protracted crisis in Syria. We've been monitoring damage for several years now. And one of the points I wanted to just highlight is basically that there's kind of an ecosystem around this, and it's split between remote analysis and field-based assessments. And so the field-based assessments, they do occur normally post-disaster, but they're resource intensive. And as such, sampling approach tends to be the preferred choice, although from time to time there have been some full building damage censuses performed, notably in the Caribbean. And when we're talking about remote analysis, it's really based on imagery acquisition, which is primarily very high resolution satellite imagery. But I also included aerial imagery, which offers a number of significant advantages. However, it's not consistently or adequately leveraged in humanitarian response yet. And then looking at imagery analysis, the gold standard is detailed manual analysis. And we do this often with our partners, UNISAT. It's very detailed, accurate, but it can be slow, definitely longer than a week typically. And if you're looking at a big city like Aleppo, it could be more than a month. There is a rapid manual option. This is usually what we call the grid cell approach. So if you can envision laying a fishnet over an area, a manual analyst will go through and come up with an assessment of damage within that grid cell. And this can be a faster result, but it's less accurate. And then what we're talking about today, so AI and machine learning assisted damage detection. And the advances are showing real promise, and there's some clear pathways for development. But I want to highlight what what we're interested in looking at, and that's creating a feedback loop between these different elements. So we're quite involved with manual imagery analysis already. And we've been working with Global Shelter Cluster and UNDP on field-based assessments for some time. But there's this very exciting space around AI-driven analysis. And some of the people that have joined us today can talk a bit more about their projects. But there's some pretty strong links between these already. So in the collaboration with WFP and Google and 510, we can provide training data from manual imagery analysis to help improve models for AI-driven analysis. We can look to further strengthen connections between field-based assessments and manual imagery analysis through ground truthing. And then in the not too distant future, we'll be able to derive sampling from rapid AI-driven damage analysis. And I'm adding aerial imagery acquisition in here because I think it offers some other benefits as well. It has the potential to both speed up and improve the quality and granularity of analysis. Often after natural disasters, we're waiting for cloud cover to clear for quite some time before we can get any suitable imagery for analysis. With aerial imagery, we don't have to wait for that. And of course, the higher resolutions available allow for better object detection. And then there's also a connection to field-based assessments. Typically after disaster, there's a conventional aerial assessment, which is often run by UNDAC and partners. But what we'd like to explore is how we can integrate some imagery acquisition to that process so we can feed into concurrent damage assessments. And so that's all I've got, hoping to set the stage with this.
Thank you, Matt. Perfect. I'm going to hand it over right off to Kyriakos for this quick pitch.
Thank you, Cristiano. Good afternoon or good morning, everyone, depending on where you may find yourself. My name is Kyriakos Kouparis. I lead the Frontier Innovations team at the Innovation Accelerator at the World Food Program based in Munich, Germany. And today I'm going to talk about a collaboration that we have ongoing with the AI research team at Google. This started approximately 18 months ago, and it is essentially, as you heard from Matt, using AI to automate damage assessments in satellite images. The project name is Sky. So the problem we're trying to tackle with this project is essentially to expedite the analysis of satellite imagery after a disaster strikes. Typically, it takes several weeks to get an accurate assessment post-disaster, and this is primarily driven by the fact that it requires manual annotation. With a machine learning tool, we're able to expedite this analysis to and reduce it from 3 weeks to 24 hours. At least that has been the case with some of the test data. I want to preface all of this that we have only been able to test Sky once recently, and we're still fine-tuning the algorithm, but I'll go into some of those details in a bit. So in a very high-level way, how does this work? Essentially, we take pre-disaster images and post-disaster images and use those to train the machine learning algorithm, which will then automatically both detect buildings, but also assess their damage level, giving them a score between 1 and 5, 5 being the most damaged. Here I have a very short illustration of how the model works before and after the disaster. You can see that it detects the buildings and then gives a score, or essentially a mark of which of those buildings has been damaged. Here you don't see the actual score, it just lists it with the red dot, but if you look at the actual data, it will also tell you how badly damaged each building is. The challenge with this model is that it's hard to generalize it. So it performs well on test data. So if we've trained it on past disasters, and if we run the model against those same cities, it performs quite well. But when you generalize the model, the accuracy goes down quite a bit. And here I'm showing examples from some of the training data sets. So if we train the machine learning model on a data set from Mexico and then test it on Mexico, then the accuracy is quite high. But if we start to train it on one city and test it on another, you see that the accuracy starts to go down, which is not ideal because we want a model that can be deployed anywhere in the world. What our colleagues at Google are experimenting with now, and in order to address this challenge, is a semi-supervised learning model in which a small subset of images are manually annotated for each new disaster, and then that subset of images is used in a semi-supervised manner to train the machine learning algorithm, thereby increasing the accuracy quite a bit. And you will see here that for these three data sets, the purple squares are the new method, and the accuracy increases quite substantially. So we are looking forward to testing this in the future to see if it does indeed perform as we think it would be based on these early results. I do want to highlight that, you know, as the World Food Program, we have a whole suite of tools that are used for damage assessment, and Matt alluded to this earlier, that different pieces, both manual, on the ground, as well as, you know, satellite, aerial, and other means, are all come together to help us manage and plan for our response in the field. And with that, I want to thank you all for your attention and looking forward to the discussion.
Thank you, Kyriakos, and straight off to Marc.
Okay, thanks, and I'll share my screen. So I hope everyone can see my presentation. I'm the scientific lead of 510, and we have been working on automated damage assessment, actually since the start of 510. And you can see also the team with whom we have been doing this work here on the slide. 510 million square kilometers is the total surface of the Earth. That's where our name is coming from. We aim to help every Red Cross national society in need by using data and digital to improve the speed and the quality of the humanitarian aid they're offering. And so far we have been working with around 30 Red Cross national societies. And actually we work with them in different phases of the disaster management cycle. Well, the first one is that we work on risk assessment for disaster risk reduction. We work also on early warning, early action, and on humanitarian response. And automated damage assessment, if we can do this real time, will of course be directly beneficial for humanitarian response, giving faster, more reproducible and auditable assessments. But actually we are also looking into how we can use it for predictive impact analytics. What you can see here is that we have been engaging with different users of these automated damage assessments by using human-centered design. So we have held co-design sessions with, for example, people from the Global Shelter Cluster and also people within the Red Cross national societies to try to design a solution that really meets the end user needs. What we found out was that it was best to have a solution that's modular, so that also secondary data can be overlaid on the automated damage assessments. Because as some people said, the needs assessment need more than just the damage. So you can, for example, see here on the right that we can add also information on vulnerability of people living in these houses, coping capacity, and information around, for example, wash facilities. We try to make sure that it can be embedded in emergency response protocols so that it's also directly actionable and scalable. So we're looking for a solution that has a fixed running time for any disaster size. And we want to make it fully open source to reach higher trust and wider adoption. In terms of performance, we have been working also, as explained by the previous speakers, on convolutional neural networks. And we have used the so-called XBD dataset. It's a dataset of 800,000 buildings that was, let's say, annotated by humans. And this was work done by, amongst others, the Carnegie Mellon University. So we used this dataset. We took out around 170,000 buildings, and we trained our model on this. You can see on the right the performance, where actually the area under the curve is, well, we think a more useful performance metric than just, for example, the F1, because it's not so sensitive to class imbalances in the data. What we found out is that if you train and test on the same disaster type and geographic region, then the scores improves. Yeah, of course, we actually would like to have more generalizable model that can also be used on unseen disasters. Well, this may be good to point out actually that what we did do was that we determined this score without using any labeled data of the test disaster during the training. So in that sense, the performance metrics you see should be really representative of a real life situation. And yeah, in terms of the way forward, we want to create area specific and disaster type specific, what we call pipelines. And here you can see how this pipeline is looking like. We use a cloud-based Azure solution. It's under development, so that we have a scalable infrastructure and a fixed computation time of around 2 to 3 hours, yeah, even with large areas affected. But actually, in order to make this pipeline work as best as possible, we need more labeled training data. And that's why we're very happy with this session. And also, we would like to reach out to the hot OSM community to together assess how we can work on this, yeah, creating more labeled data sets. And I actually also wanted to point out that actually Jacobo Maguti from our team, he is currently deployed to the Philippines, let's say really directly working with the end user as an information manager for the global shelter cluster. So also that we want to use to, yeah, to learn from these experiences. Over to
thank you so much, Marc. And Antoni, after you. We cannot hear you, Tony.
Can you hear me now? Hello?
Yes.
Sorry, I'm sorry, I'm having some technical issues. Okay. Hi, everyone. Sorry for that. And thanks again, Cristiano and Marc and all for your presentations. My name is Tony. I am the lead for the disaster services team at HOT. And today I will be talking a bit about the machine learning labels for damage assessment in OSM project. I will try to be aware of time and go a bit quick through it. This project aims to leverage OpenStreetMap and its community of humanitarian mappers to create training labels for machine learning algorithms to identify damage after a disaster event. It plans to do so by drastically reducing damage assessment from 1 to 5 days to just few hours after receiving the post-event imagery. It aims to train a team of experienced validators that will double the rate of manual damage assessment from typically 100 buildings per hour to over 200. It plans to do so using an integrated artificial intelligence assisted mapping tools. It will define a unified and agreed set of damage assessment tags directly into the USM data model, and it will provide an open workflow and tools to perform damage assessment on disasters that are usually not covered by international response. This type of disasters tend to account for more or less 80% of the events. This project, sorry, will be divided in 3 different phases. On the first phase, it will be focusing on piloting damage assessment tags in OSM, and it will be doing so by setting up pilot projects to create label data for different disaster scenarios and hazard types in a separate OSM environment, as an example, the OSM seed environment, and by developing a hybrid environment with damage tags available in OSM editors, such as the ID editor and JSON, that are being saved in a private database. Second phase of this project will be focusing on OSM tags and guidelines. Its activities will be focusing on leading the proposal of a submission and the community engagement side for embedding damage tags in OSM data model as feature status / condition attributes. As an example, we could talk about the breach, impassable / damaged. It will also create guidelines for damage mapping in hot activation, and it will be deploying and testing damage tags in official public activations. Lastly, phase 3 will be focusing on implementation of machine learning. It will do so by assisted damage assisted damage classification in OSM. Sorry, assisted damage classification will take place in OSM by using the output of machine learning models, using the same approach as with the rapid ID editor. Models will be refined with validation from expert OSM mappers, and APIs for label data and damage assessment output will be deployed. On a final note, this project is envisioned to take place from January 2021 to June 2022, and it has already opened collaboration opportunities with partners such as the Netherlands Red Cross and the 510, as Marc just mentioned, and the Global Fund for Disaster Risk Reduction to implement post-disaster needs assessment, as well as opening opportunities to many local communities trying to carry away or improve post-event assessments. Thank you so much for your attention. Please don't hesitate to use my contact details for any further information. I'm looking forward to the discussion.
Thank you so much, Tony. And we have 4 minutes that I think we can still use. So I think I'll just throw in a quick question, and I hope everyone on the panel can say their opinion on this. But there have been past events where data on damage was directly added into OSM, but the process and the tags were never formalized. And there are several community members that in OSM that see this type of information as temporary. But at the same time, we see the potential of leveraging the OSM infrastructure and crowd and the community to really create this type of damage information that is so critical for many of the organizations. So what do you think are the ways in to do this, and what would be the challenges, and how do you see the machine learning fitting into this approach? So maybe in the same order that we started, Matt?
Yeah, so I mean, I think it's possible to come up with a standard tagging scheme. I know UNHCR recently have worked on doing exactly that for camp settings in OSM. So I think it would take an effort, but I think you could get there. I think the bigger issue would be about integrating AI and trying to validate the work of some of the OSM contributors. So you'd have some manual tagging, and then how do you integrate the AI at that point? I guess another question, so I'll answer that.
Yeah, thanks, Matt. Kyriakos, from your experience?
Yeah, I would add to what Matt said in that it would also be a factor of how quickly the OSM network can be mobilized and how quickly that label data can be received. Because the whole premise of using machine learning based tools is to expedite manual processes that take quite a long time. So I think the temporal aspect would also have to be taken into account.
Yeah, definitely. And Marc, what do you think?
Yeah, I think this would have really a lot of benefit also to, for example, track recovery of communities over time. If we could see at which point houses are recovered, for example. But I guess that would require regular, let's say, labeling. So that might be quite difficult to achieve. And also we might have, of course, areas with rapid urbanization. So then the labels from a few years ago might no longer, let's say, fit. So yeah, those are some technical challenges, I guess. But overall, this kind of information to keep track of this over a longer time period are very useful.
Tony, I'll let you close. And I mean, the approach that you outlined in the project that we're planning, hoping to do, kind of reflects this approach to go stepwise, so not to directly add all this information to our sim, but have a more conservative approach and have separated environments to start. So I'll let you say some closing remarks, and then I think we're right on time to finish the session.
Thanks, Cristiano. And I definitely agree, although it is true that might become a burden to keep this data up to date. It is a better reflection of the actual status of the field, if for lack of a better name. So it is more, yeah, it is a better reflection. And as Cristiano just mentioned, the idea of leveraging machine learning to support lessening this burden, as well as utilizing the whole community to get involved in the process and see the benefit from it since the beginning, as well as testing it in a separate environment, are definitely key components to build this idea through success and make the most of this project. So yeah, that will be my take. Thank you, Cristiano.
Thanks, Tony, and thanks everyone on the panel. And we'll take some of those questions and put them in a separate chat for the panelists to respond. And I'll hand it back to Lily. Stay in touch and let us know if you're doing any work related to damage assessment. We'll be happy to collaborate and cooperate with you. Thank you.
Thank you so much, Cristiano. Wonderful, everyone who gave us talks on that. Thank you. And I'm happy to welcome Jeff Underwood and